Have you ever wondered what would happen if we set off a massive nuclear explosion on the moon? It sounds like science fiction, but let's use science to explore this wild idea. The moon seems delicate in our night sky, but it's a tough ancient world that survived billions of years of impacts. This thought experiment isn't about actually doing it. It's about using curiosity to understand physics, explosions, and the nature of celestial bodies. Believe it or not, during the Cold War, some even considered nuking the moon to show off power. Thankfully, it never happened. Today we can use computer models and our knowledge of science to predict what would happen. No real explosions needed. So let's dive in. What would it take to nuke the moon, and what would actually happen if we did? We'll look at the differences between explosions on Earth and in space and just how tough the moon really is. By the end, you'll see the moon not just as a light in the sky, but as a resilient neighbor shaped by cosmic forces. Let's get started. First, how would we even get a nuclear bomb to the moon? It would take a powerful rocket, like those used in the Apollo missions to escape Earth's gravity and travel nearly 400,000 kilometers through space. The bomb, imagine the massive Tsar Bomba, would be heavy, requiring careful engineering to survive launch and space travel. Mission control would have to guide it precisely, aiming for the side of the moon facing Earth so we could observe the results. Timing and trajectory would be critical. One mistake and the bomb could miss the moon entirely. Once there, we'd need to trigger the explosion either remotely or with a timer. The detonation could happen just above the surface for maximum effect, or on impact for a different result. Each choice would slightly change the outcome, but the planning would rival any lunar mission. Moving objects between worlds is one of humanity's greatest challenges. But let's say we succeed, what happens next? Time to find out. Could a nuclear bomb actually destroy the moon? In short, absolutely not. The moon is staggeringly massive, about 73 quintillion kilograms. Our biggest bomb is a firecracker compared to that. The energy needed to blow the moon apart is trillions of times greater than anything humans can create. Even the largest asteroids to ever hit the moon, far more powerful than any bomb, only left craters. The moon has survived billions of years of cosmic impacts and remains intact. A nuclear explosion would be dramatic, but it wouldn't threaten the moon's existence. The moon is a solid, massive ball of rock, not a fragile shell. You could scratch or dent it, but breaking it apart is far beyond our reach. The moon is here to stay, no bomb can change that. But what would the explosion actually look like? On Earth, a nuclear blast creates a giant mushroom cloud, but the moon has no air, so things look very different. There's no sound, no mushroom cloud, just a blinding flash of light and energy. Most of the energy would be released as X-rays and high-energy radiation, instantly vaporizing lunar rock at ground zero. The rock would turn into a superheated gas, blasting outward in all directions. This cloud of vaporized rock and dust would carve out a new crater and shower debris across the surface. Some particles would be ejected into space, but most would fall back to the moon. The explosion would be violent, silent, and starkly beautiful, unlike anything on Earth. No fireball, no shockwave of air, just raw energy and matter in motion. The moon's weak gravity means some debris escapes, but most settles back down. So what's left behind after the blast? The most obvious result would be a new crater about 1 to 2 kilometers wide for a bomb like Tsar Bomba. On the moon's vast surface, it would be just another scar among thousands. The intense heat would melt surface rock, creating a glassy layer called impact melt. Surrounding the crater, a blanket of dust and rocks would cover the landscape. Radioactive particles from the blast would settle on the surface, making the area dangerous for future missions. The blast zone would remain radioactive for thousands of years, but the moon's structure and orbit would be unchanged, no cracks, no shifting in space. From a distance, the moon would look the same as always. The explosion would leave a small, radioactive mark, but the moon would endure. So would we even notice anything from Earth? If you watch the moon at the moment of the explosion, you might see a brief, bright flash, like a new star, if it happened on the dark side. After that, the moon would look exactly the same to the naked eye. The new crater would be far too small to see from Earth without a powerful telescope. The dust cloud would be invisible, and the moon's glow would remain unchanged. For most people, there'd be no sign anything happened at all. The moon would continue its steady orbit, unchanged and resilient. Nuking the moon would leave a tiny scar and a radioactive mess, but the moon itself would endure. This thought experiment shows just how immense and tough our cosmic neighbor really is. And it reminds us, just because we can imagine something doesn't mean we should do it.